got your back.
She said, get lost or what?
She just gave me a cough drop.
Yeah, because you're over here laughing. It is funny.
All right.
I knew
So-
you'd be back.
We have
He's gone for more than
one
5
section
minutes.
to finish up. Tomorrow is review day, and then our test will be on Thursday. Okay? And that'll be our first chapter test. Quiz-wise, I did get them graded. I did not put them in yet. I was going to kind of let you guys correct them, and then I'll put them all in. So probably today I'll get them put in. If we have some time at the end of the hour today, I'll get them back to you. If not, I'll pass it back to you tomorrow, and you guys can correct on review day. But overall, I thought quiz grades are pretty good, and so it's good score to start off
Excuse me
with
for this
most.
announcement. If any students are having issues with technology with Hutchinson Community College, please at this time bring your computer and go to the library conference room. Again, any student that is having technology issues with Hutchinson Community College, please take your computer and go to the library conference room.
Are they going to
Thank
send you back too?
Yeah.
If you can go tomorrow, please go during pass period. Thank you.
Yeah.
Yeah, no. All right.
I had it last week.
Wow. Don't mess with this. Can I touch it? Make sure you don't pull it. Buddy, do you want to sit next to each other? Should I just come over here?
Bro, we're gonna be back.
No, you're not.
Okay. So throughout chapter 1, it's just been a little bit of everything, right? It's just kind of been like the basics of algebra, things that make up everything we do. So we've done properties, we've done types of numbers, we've done order of operations, solve some basic expressions. Today, we're going to talk about writing and looking at and evaluating different types of expressions. Well, what makes up an algebraic expression? First of all, we have to have some type of operation. And so today we're going to have both what we call a verbal expression and then the algebraic expression. The verbal expression is like how we say it or write it in words, and then the algebraic expression is how we put it into an expression with letters and variables and numbers and signs and operations. So the first thing we're going to kind of go through is talk about our 4 operations. And when I read maybe a story problem or maybe just a verbal expression, what are some words that I look for that tell me that I am adding? Plus, okay. So, yep. Okay, any others that you guys can think of? And it may not just be a single word, it may be a combination of things like more than. If I have 2 more than somebody else, that means I have whatever they have plus 2, okay? So I could say more than, or, and sometimes we will see increased by. So those are just some common words associated with adding something to an expression. Okay, subtraction. What are some common ones? Minus, yep. Difference, good. Less than, yep. Now it's just kind of the opposite of adding. Now remember, this is not like your less than symbol. This is 2 less than something. If I have 20 pencils and you have 2 less than me, then I would take 20 minus 2. Or just the opposite of the last one, decreased by. Okay, then we have multiplication. The answer to a multiplication problem, what word do we use? Okay, we could say times. Product, yep. Hey, and then you have some specific ones, like if I multiply by 2, we might say that we're doubling, or I have twice the amount, or triple the amount if it's 3 times. And so sometimes you might see specific types of multiplication where it's not for everything, but it would still mean multiplication. And then our fourth operation is division. The answer to a division problem. Yeah. Quotient, yep. Okay. Ratio is something we don't necessarily always think of. A ratio we think of more like a fraction, but a fraction, what are we really doing? We're dividing, right? And so a ratio would be like 2 to 3, would be the same as 2 divided by 3. So it's still division, but we might write it as a fraction. So a fraction can also be thought of as division as well. Some of the things that we are going to be doing with this, and so those are your 4 operations. We could also see some exponents. And when we talk about exponents, we talk about to the power of, like 2 to the 3rd power. What power would be my exponent. And then you have specific exponents, like squared would be 2, cubed would mean 3, something raised to the 3rd power. So still exponents, but we're looking at more like specific types of exponents. Okay, and then another one we might see a little bit is roots, but we don't really have any specific, like square roots, cube roots. They're going to come out specifically and tell me what type of root we have. And so not really any specific words there that we're looking for. Okay, so when we talk about a verbal expression, we're talking about writing the expression out in words, okay? And so we're going to use some of those key words that we just talked about. And then we're going to go back and forth from a verbal expression to an algebraic expression and vice versa. So I'm going to give you an example here of a verbal expression, and then we are going to write it as an algebraic expression. So we're going to say 4 more than 3 times number. Hey, and really the goal here is just to kind of look for those keywords, right? Things that we just talked about, things that'll tell us what's happening, what operation we've got going on. And in some cases, what's going to happen is they're just going to say a number. Well, if they don't dictate what that number is, then that's a variable. Sometimes they might say a number X, and so then we know what variable we're going to use. If it was a story problem or something like that, they might be using like D for dollars or something like that. So it might represent something in like a story situation. But if it doesn't say what variable or what the number is, then we might just call that X. Okay, we know times, we just talked about, means multiplication. More than means addition. Okay, so those are some of the key words that we're looking for. So really just as we go left to right, just like we would read a book, we're going to kind of rewrite this with our operations and with our symbols into an algebraic expression. So we're going to start with 4. More than means addition. 3 times a number. Okay. And that would be our expression. So obviously the algebraic expression is a whole lot easier to write, or a little bit less work to write than what the verbal expression is. If I gave you the algebraic expression, we would just have to go the opposite direction. Now, what could I write this? Would this be okay? Yeah, okay, those are the same thing. Because remember those properties we talked about, commutative property of addition. So first of all, I don't necessarily need the multiplication sign here because if it's 3x, it means 3 times x, okay? Plus 4 could either be at the beginning or the end, okay? If I add 4 to 2, doesn't really matter what comes first. 4 plus 2, 2 plus 4 still gives me 6, right? So same thing to 3x. When I add 4, I can add it either direction and still end up at the same result, okay? So some of these, there's going to be more than one way to write it. But if this was subtraction, then that would be a little bit different, right? And that's why, like, when we did those properties, we had properties of addition and multiplication, but we didn't really have properties of subtraction and division. And so that's why sometimes it works for some things, but not for everything. So either one of those would be perfectly acceptable ways to write that. Here's another one. 6 less than the square of a number. Okay, and we did talk about going left to right, which is true, but here's where we kind of got to be a little bit careful. Okay? First of all, they do not tell us what the number is. So what variable you use, unless they say let's use x or let's use n or whatever it is, then we're just going to pick a variable. Okay? X or n or whatever variable you want to use is fine. Sometimes they'll tell you what variable to use. In this case, let's just pick one. Okay, so there's two different ways that this could be written. 6 less than the square of a number, means x squared, or x squared minus 6. Are both of those the same, and can we write it either way? Okay, so let's think about this. If I said 4 minus 8 and 8 minus 4, are those two things the same? No. Okay, so that's where we got to be really careful. Up here it was okay, right? Flipping them around, no big deal. Because when I add something, it really doesn't matter what comes first or second. But when I have subtraction in between two things, then one of those is correct, one's not. Okay? And so if I said 6 less than something, if I had 20 pencils, let's go back to that example. If I have 20 pencils and I have 6 less than that, how many would I have? 14, right? So I had to take 6 away from 20, not 6 in front of whatever it is, okay? So this, even though as we read a left or right, we think we're going to put that 6 in front, but we're taking 6 away from whatever that expression is. So this expression would not be what we want, okay? This was not going to work. So this would be the correct way of writing that, okay? And not both of them would be okay. So once again, it kind of depends on the operation. Addition and multiplication, same thing here. I could say x times 3 or 3 times x. Typically, we put the number in front of the variable, but either one of those would be okay. X times 3 and 3 times x are the same thing. But when we have multiplication or division, or sorry, subtraction or division, that's when we got to be really careful of our signs. Okay, if I wrote out something like this and asked you to write the verbal expression that would represent this algebraic expression. So they already wrote it out with numbers and operations and variables and all that. Now we're going to write it out in our own words. Okay? And once again, there could be more than one way to say this. Kind of like when we did addition, we said there's a lot of different ways to say addition. You could say sum, you could say more than, increased by. Okay? And so there's a lot of different ways to say this sign right here. But what I would say is kind of start like you do with order of operations. So if I was going to do order of operations here, which operation would have to come first? Addition or division? Division, right? Division, multiplication and division comes before addition, subtraction. So I would say a number y divided by 5 then increased by 4. Okay, and the key here, and the way I like to write it is I like to write the word then. That kind of separates those. We're going to do this, and then we're going to do this, okay? Now, I could say 4 increased by the quotient of y and 5, right? There's so many different ways. I could write this a lot of different ways, okay? So what I want you to realize is, like on the test that we take, or on your homework today, when we write these out, I might have something written, but that may not be the only way for you to write it out, okay? So if you have something else a little bit different, just look at it, and if you have any questions about if it's correct or not, just let me know. But there is more than one way to write it. So it doesn't have to be written the way that I wrote it, okay? And for me, as like grading a test or something, that's kind of hard for me to decide. I just have to look at it and see if it makes sense. Okay, another one that we're going to do here is kind of along the same lines, but this one, we call it a verbal formula. So this is more like a formula, and we've seen a lot of formulas throughout the years, right? We've seen formulas for different geometric figures, or we've seen like midpoint and distance, and there's tons of formulas out there. And we could say it in our own words, right? And that would be the way that we're going to write it out. So I'm going to write out a formula here, and then we're going to change that formula into its algebraic form. So this one, we're going to go ahead and dictate what the variables are. Because it's a formula, those letters, those variables are representing something specific. So I'm not just going to typically pick whatever variable I want to on something like this. Because when we talk about an area of a triangle, I want to know the base. I want to know the height. And we use B and H to represent this. Another one that we would probably use here is area, okay? And whenever we've talked about area way back when, we would use maybe like capital A. A represents area. So area is, whenever we see the word is in math, is always means equals, okay, which makes that an equation. So area is 1/2 the product of the base and the height. And that would be our algebraic expression. Okay. Now, is there other ways to write that? You bet. Like, you probably remember area of triangle looking something like that. Base times height divided by 2. Okay? Same idea. And so then we could say it verbally other ways, but we also can write it algebraically different ways too. The same math is still going to get applied to it. Okay, we're going to have a couple of these problems today. They're going to give us an algebraic expression, and they're going to ask us to evaluate the algebraic expression. So I'm going to give you an expression here, and we're going to try to decide what my solution or what my answer would be if I evaluate it. So we're going to start off with an expression, not an equation, no equal signs here, just an expression. And our goal here is not to rewrite it in words and all that. Our goal here is to evaluate it. So for part A, we're going to do two parts here. We're going to plug in x equals -3. And when I plug in x equals -3, wherever there's an x, that -3 has to take its place. So we're going to go 4 times -3 squared over -3 minus 6. Okay, and this kind of goes back to what we did earlier in the chapter, is just order of operations, right? We got to do things in the correct order to make sure we get the correct answer. What would we do first here?
You can do a lot. Parentheses. You can do parentheses.
Okay. Do we have an operation inside the parenthesis?
No. Say it's 4 times -3 to the second one.
Okay. But what we got to remember is PEMDAS, we got to do the exponent before we do the multiplication. Okay. So what we don't want to do is we don't want to multiply this first. We want to square it first. Exponents come first. So -3 squared would give me what?
-9.
Close.
Oh,
Because the -3 is in parentheses. 9, positive, because it would be -3 times -3. So that would be 4 times 9. Because -3 minus 6 is all on bottom by itself, I could go ahead and simplify that. Okay, you might say, well, I did subtraction before I did multiplication, but they're separated by the division sign. Okay? And now we can do the multiplication. If you want to do the multiplication first, that would be okay too. 36 divided by -9 would be -4. Okay, so we're just simplifying it. They tell us what the value of x is, and I could take this problem and I could do it like 10 different ways, right? I could take a different number, plug it in, and get a different answer. So I could keep evaluating, give you different values of x, and we're going to get different answers whenever we do that. Now, if I said, let's plug in x equals 6. Same thing. We're going to go 4 times 6 squared all over 6 minus 6. So we go through order of operations, very similar to what we did on the last one. Exponent first, 6 squared is 36. So this would be 4 times 36. And we have 0 on bottom. Okay, what happens when we have 0 on bottom? It's no solution, it's undefined. Okay, you can never ever divide by 0. We can have 0 on the top of a fraction. That's okay. 0 divided by anything is still 0. If I don't have something, doesn't matter. I can't divide it, right? But I can't divide by 0. If I have a big pizza and I say divide that into 0 slices, it's impossible, right? I got to cut it up somehow, and there's no way to cut it into 0 slices. It already exists. So dividing by 0 can't happen. So that's always undefined. So anytime we get 0 on the bottom of a fraction, we always know something's wrong. We can't do that. We could also just look at an expression, and we could just answer this question. What value of x makes this expression undefined? Yeah. -4, okay? We just got to decide what is going to make this 0, right? If I put -4 in for x, -4 plus 4 would be 0. The 0 is on the bottom. There's nothing about the top that we have to worry about. We can have 0 on top. So only the denominator is what we're worried about. And so x cannot be -4. Okay, and so we always just put an equal sign with a slash through it, because we can put any value of x we want to into this expression except for -4. Every value of x would have a value except for -4. The other day, we talked about some of these properties, and I told you this was probably the most common property that you have done, okay? And when we did it the other day, we did it more with just like numbers and talking about the order of operations and how we might use the distributed property. But when you solved equations way back, even like in Algebra 1, when we solved the distributed property, or simplified the distributed property, all we're doing here is simplifying the expression, okay? If I don't know the value of x, I can't really get a solution here. I'm just going to simplify the expression, and whenever we distribute, we take whatever's on the outside and distribute it to whatever's on the inside. So 3 times x is simply just 3x. 3 times 4 would be 12. Okay. Can I combine 3x and 12 together? No, because what we say is they are not alike, right? They would either both have to be numbers or they would both have to have x's. Right now, they're not alike. So we cannot combine them together. So that's my answer. That is my expression, 3x plus 12. That's all I can do. That's the way we're used to seeing it. Typically, the number is in front of the parenthesis. I could also give you one like this. We're probably not quite as used to seeing something like this. Okay, and this is not minus 4. You got to kind of be careful with this sometimes. This is a -4, and that's why sometimes when we put it at the back of this, it kind of gets a little bit tricky. But we're going to take this -4, and we're going to distribute it to both again. So this would be -24 plus 20y. Negative times a positive is a negative. Negative times a negative. That minus sign stays in front of the 5, makes that a positive 20y. And once again, that's as far as we can go. That's as simplified as we can get. Okay, a couple more vocab words here real quick. Whenever we talk about a term, a number or product of a number and one or more variables. Okay, so some examples of a term. I could just give you 8. 8 is a term. 8 is 8, right? 2y. 2 times y. It's a product of 2 and y. I also could add a bunch of variables to the mix. I could say 7 ABC. 7 times A times B times C. All of that is being multiplied together. In order to be a single term, we can only have multiplication, okay? No addition or subtraction within that. Okay? So if I have any addition and subtraction, then that makes it a multiple term, more than one term. Okay, another vocab word. This is one we see a lot in algebra, is coefficient. When we talk about coefficient, what are we talking about? What would it refer to? Any ideas? So if I said 2y is an expression, what would be the coefficient of 2y? 2, yeah, 2. It's the numerical factor in So if I had 3m, 3 is my coefficient. Doesn't matter how many variables I have. We're just looking for the numerical factor. There should only be one numerical factor in that term. Okay, we talked about this just a second ago. But if I have like terms, it is two or more variable terms with the same variable and same exponent. Okay. And when I talk about constant terms, it could just be numbers too, right? I could say 2 and 3 are alike because there's no variables attached to them. So I can combine 2 plus 3 because they're just numbers. Okay, so like terms here, I'm going to give you a couple of examples of things that are alike, and then I'll give you a couple of examples of things that are not alike. So 3x squared and 5x squared are considered to be like terms. They have the same variable, same exponent on that variable. The number in front doesn't really matter because then I could do like addition and subtraction and some type of operation with those terms, and what we would say is we're going to combine like terms. But here we're just talking about what makes them alike, and that would be same variable, same exponent on them. Okay, so what are some examples of unlike? Obviously, can't have the same variable, right? If one's got x and one's got y, they are different, so they cannot be combined together. So those two terms are not alike or unlike. I could do 5x squared and 6x. Those are not alike. They do share the same variable, but one's an x squared and one's just an x. So those could not be combined together because they don't have the same exponent. So just trying to look at them and decide what we've got. Okay, the last couple of examples here, that's what we're going to talk about, is how do we combine like terms, okay? And this is something that we've done as we've solved equations for a long, long time, okay? But just kind of looking at it in some different examples here. We'll start with a real basic one here. 10x plus 7y minus x plus 6y. We have things that are alike here. We have x's that are alike. And one thing that I kind of like to do sometimes is I kind of like to underline the things that are alike the same way, just to show those are the things we're going to combine together. If there is no number in front of the x, what would the coefficient assume to be here? 1. Yep. Okay, and we don't necessarily have to put a 1 there, but we do got to remember that it's there. Okay, because if I take 10x minus x, I got to remember that this is 1x. And so 10x minus 1x would become 9x. And then we're going to combine our y's. 7y plus 6y would be 13y. Okay. We can't combine those together because now they're not alike. This one has an x, this one has a y, and they are not alike. So that is as simplified as that expression could be. Would it be okay if I flip-flop these two? What if I said 13y plus 9x? Would that be okay? Yeah, okay. So it doesn't really matter which variable you list first. Kind of a rule of thumb is what I usually do is go alphabetically, but it doesn't necessarily have to be that way. Eventually, when we start looking at exponents, we'll go from like the highest exponent down to the lowest exponent when we have multiple exponents, but that's still a ways away. Okay, let's do one more. This one a little bit more involved. Okay, so the only thing we see in here are H and K's. But before we start combining like terms and doing all of that, the first thing we got to do is we got to try to simplify the expression. And what would we need to do first? Yep, distribute. Get rid of those parentheses. So this is kind of a combination of a bunch of stuff that we've talked about today. Get rid of the parentheses first. We're just going to rewrite the expression. The first part of it is going to stay the same, 3h plus k, minus 10h, minus 6k, minus 9, plus 5k. Okay, so now we got just a bunch of separate expressions. We got some h's. We got some k's. And then we got a number that doesn't have either h or k. So we call that a constant. When we have a 9, it's just going to stay 9. We can't combine it with anything else. Okay? And like I said before, it doesn't really matter what comes first here. 3h minus 10h become negative 7h. If you wanted to start with k's, you can start with k's. Okay? That doesn't necessarily matter a whole lot. Okay? Don't forget that there's a 1 in front of this k, so we're going to do 1 minus 6, which would be negative 5. Negative 5 plus 5, what happens to my k's? Yeah, they're gone, right? No k's, 0 k's left. There's nothing to write. Can you write 0k? You could, but we really don't need to, right? There's no k's left. They're all gone. And then we still have the minus 9 at the end. So that whole thing simplifies down to that. Okay. All right, that's all we got. That is chapter 1 for us. Okay, evens on the first 3 sets. It probably is a few more problems than what we typically would do, but a lot of these are just going to be look and answer. I think what I'll do is probably wait till tomorrow to pass back your quizzes. Because then you can correct them and we'll do that on review tape tomorrow. Okay. So not as much time between quizzes and tests, and that'll be kind of normal because these chapters just aren't very long. But I still like to do quizzes and tests, and I think that gives us a good idea of some of the things that we need to be ready for. Okay. So essentially your test on Thursday is only going to be this added on to what we did for the quiz, okay? And we did pretty well on the quiz, so now we'll just have some of this stuff added in, and that'll be what makes it work.
The test on Friday?
Thursday.
Oh, I'm gonna be gone. Why? You signed my paper.
I know.